So the way that we measure earthquakes is with two different scales. So let's talk about the first one, which is one that you've probably not heard of very often, and that's the modified Mercalli scale. So the modified Mercalli scale kind of works like the Fujita scale, in which you look at the damage that is done, and then you assess a number to it. So a number of 1 is low damage, right, and it goes all the way up to a 12, and a 12 is high damage. So you can see here on this diagram, right, if the epicenter there is in red, right, well, you're going to get these radiating circles around it of high damage, right, to low damage as you move through. However, the problem with this is a really subjective scale. So what happens is most of the time insurance companies tend to use the modified Mercalli scale, which shouldn't be a surprise, because what might look like a 4 to me looks like a 1 to you, right? So we generally tend not to use the Mercalli scale in science. Let's see. So what we tend to use is the magnitude scale, and you've probably heard of the Richter scale, right? So this is what we use. So we're measuring the seismograph itself. So we're taking the largest wave you can see here and measuring the amplitude. And that amplitude is actually going to give us information about how strong the earthquake is. So the bigger the amplitude, or the stronger the wave, right? The smaller the amplitude, the smaller the earthquake, right? So we're measuring the moment, right? So physically we are measuring one moment in time to figure out how strong that earthquake is. Now, the thing to realize about the Richter scale, or magnitude scale, is that it is logarithmic. So as you see here, right, a 6 is 10 times greater than a 5. So that's why you've heard of maybe a 5.5 before, or a 5.6, or a 5.7. Those decimal points, right, increase every time. So a 6 is 10 times greater than a 5, and a 7 is 1,000 times greater than a 4. So let's put this here into something that we can kind of grasp when we look at the Richter scale. So here we've got a diagram that equates earthquake size to energy equivalent that you might know, right? So an earthquake that has a magnitude of a 3 is the equivalent of a lightning bolt, right? So that's why we don't really feel 3s. We don't really feel too much of anything below a 3.5. However, when we start getting into bigger ones, right, here we have a 6, right? Well, that's equivalent to Hiroshima. That's pretty major. A 7 is equivalent to a hurricane, and as we know, hurricanes are pretty major, right? So an 8 is equivalent to Mount St. Helens, which we talked about, and you saw some videos about. A 9, right, is right all the way up here, right? A 9 is some of our second highest earthquake that we've ever had. So that we really don't have any other energy equivalents here, only because you can see some of our largest equivalents, right? There's a H-bomb, Krakatoa eruption. So once we get into that 9-10 range, they release so much energy, it's almost unfathomable. Fortunately, anything in the 8.5 to 10 range is beyond rare. The strongest earthquake we have on record is a 9.5. So, right, definitely they're strong earthquakes, but we don't really see them occur that often, thank goodness.